missing values, right. So what do I mean by missing values?
Some features.
Class is a different thing. We'll talk about class much later. Suppose I have, again let's go back, take a real scenario, right. You are filling in some survey questionnaire, and then I am going to take all the data from you, and then I am going to build a decision tree that allows me to predict whether you will buy a machine in my, or buy a new computer from a shop, or a new TV from a shop or something, right. And then the next somebody comes in, and then I am supposed to just look at you and say, okay, he's going to buy a computer, he is not. Right. So I should be able to classify people like that, but then when I fill in the survey, I might just not answer some questions, right. So I will have a data point, right. So I am assuming that xi is drawn from Rp, right, or whatever, right, whatever the space that I am drawing xi from, but for each xi I assume I already know the values xi1 to xip, right. So far we have never talked about the case where some of these might be unknown, some of these might be missing, they might be missing for a variety of reasons, right. So one could be, right, there could be a no response in a survey or something, right. The other could be due to noise removal. What do I mean by that? I look at my patient record data, I find that somebody has a temperature of 223. So obviously some noise there, right. Do I make it 22 or 23, I mean, or 22.3, right, nothing seems right, right. I don't tell you what scale it is in, but still doesn't seem right. So what do you do? Just remove it, okay. So let us just assume that the nurse did not record the temperature of this patient, right. So you remove noise from your data, you might lose some attributes. I have everything else about the patient, I just do not know whether he was running a fever or not when he came into my clinic, right. So likewise you could just not have recorded it, right, that is equivalent to no response. So that guy might have come with a, like a bleeding right hand with his just hanging off a wrist or something, and you are not going to say, hey, first get his temperature and put it in there, I do not want any missing values, right. Right. So the things just might not just get recorded, you know. So those kinds of things are there, it's equivalent to no response, right. So anything else? Yeah, exactly, that is what I was going to say, malfunction, right. So it is just that you might be recording sensor data from somewhere, and then the sensor just turns off for a while, right, maybe it overheated or something went wrong, and just for just a while you do not see any of this data being recorded. So there are a variety of reasons why you could have missing values in your data. In fact, if you work with real data, right, more often than not you will have significant missing values, right. In fact, when I work with some data, I have had cases where people have given me data where some attributes were missing in more than 80% of the data points, right. So what do you do in that cases? Remove the attribute itself, okay. You might as well not worry about the attribute because you are not going to be able to use it in any practical setting, right. So we just remove the attribute itself. But in other cases, if it is missing only in like 5% or 10% of the data points, you do not want to throw away that data point, right. Throwing away 20% of the data point is still a big thing, right. And yeah, so and you do not want to remove the attribute also because it is available in 80% of the data points, right. You do not want to throw the attribute away, you do not want to throw the data points away, right. So there are two things, you can throw the column away, you can throw the row away, right. If it is missing in more than 80%, you can directly throw the column away, but it is somewhere in the middle, right, somewhere small numbers, then you do not know what to do, throw the column or throw the attribute, throw the row, do not both, huh? Exactly. So there are lots of different ways of handling this missing value. The statisticians have studied these for eons, right. So they have come up with many techniques for handling missing values. And why am I bringing it up while we are talking about decision trees and not other classifiers? Because there are some techniques which are peculiar to decision trees, okay, which are not available for other classifiers. I am going to talk about all of these, right, so that I mean in general also you could use some of these techniques. The first one, right, so we will give it a fancy name. Called imputation. Right, imputation is essentially filling in a value for the missing attribute. Right, so how do you fill in a value for the missing attribute? Do the mean. The simplest thing is to do the mean. Right? You could do a regression on the attribute, right? So you could regress on the attribute. In fact, what is the best way of doing regression on the attribute? Is to do it in a class conditioned fashion. Use the class also, because you are talking about the training data here, right? So use the class also as in part of your regression or part of your averaging. So what you can essentially do is, okay, take all the data points that are of class 1, okay, and use those to predict the value of the missing attribute for in that set of data points, right. Suppose I have like 100,000 data points and let us say 1000 are of class 1 and of which 4 of them are missing some attribute 3. I will just take those 1000 data points, right, I will do a regression and predict for those 4 data points. I will use the remaining 9996 data points as my training data and fit the curve, and now I can predict what that one missing point is. So why is this kind of conditioning on the class useful?
Because it would help you use that feature in turn to guess the class.
So if there is any kind of variation, right, the correlation between that feature and the class, right, this will help me preserve it, right. If I am going to do this across the entire 100,000 data sets, I will lose the correlation, I will lose the effect, right, at least for these attributes it will get polluted, right, but this way I will be able to retain it.
So what if there was no correlation?
You do not lose anything, you do not lose anything by doing it this way. Right, if there is correlation you actually preserve it, if there is no correlation you do not lose anything by doing it.
Attribute has no relation to the actual class itself.
I'm sorry?
That particular attribute you are using has no relation to the class.
That is exactly what he was asking. He is just saying what if there is no correlation, you do not lose anything by doing it this way. Yeah. Right. So this is imputation. There are different ways of doing imputation. You can use the mean, you can use the class condition mean, right, you can use regression for doing the imputation, and now there is something really more complicated technique, that is something called multiple imputation, right. Oh, and using the regression for doing the imputation is also called full information imputation. I told you the statisticians have been at it for a while, right. So they have all kinds of, so full information imputation is because you are using all the known attributes for predicting the unknown attribute, right. When you are doing the mean you are only using that attribute in the same attribute in the other data points, right. And multiple imputation is a little weird thing. So what you do is you use all the data that you have, right, and set up a probability distribution over the missing attribute values, right. Like I said, I have 996 data points in which that attribute is not missing, right. I will use that and figure out, okay, for red what is the probability, for blue what is the probability, for green what is the probability, for discrete ones it is easy, right. For continuous values I will have to pick some distribution, let us say I pick a Gaussian, right. I will say, okay, I will find what is the mean and the variance of the Gaussian that will predict the missing attribute value, okay. Now what I do is I draw samples from this distribution, and use those samples to fill in the missing values, I will get one data set. I can draw another set of samples and fill in the missing values, I will get another data set. That is why it is called multiple imputation. So, I can create multiple copies of the data point by repeatedly sampling from this distribution, and in some cases this has much better variance, right, much lower variance than using some of the other methods. So, even though this entails significantly more computation. Right. Okay, so imputation is one. There is another there is another way to handle this. I just introduce a new value for the variable, right, and I will call it missing. Why would this be useful?
The data might be missing for some reason.
Exactly. So, there might be some kind of systematic reason for which the data goes missing, and if I, instead of trying to somehow guess what the value should be, if I actually pay attention to the fact that it went missing, right, that would be useful. So, I did not see who said that. Okay, fine. Yeah. So, in fact it is actually a very practically useful thing, right, because quite often the reason it goes missing is there is a specific reason for it, and you can, in fact the fact that it is missing might be predictive of something, So, how likely is my patient to recover? The temperature reading is missing. Right. So, those kinds of things. So, use something called surrogate splits. So, what is a surrogate split? Okay. So, surrogate splits actually serve a slightly different function, right, both for imputation and this can be used during training itself, right, but the surrogate splits thing we typically use during testing. You can also use it during training, I suppose. The basic idea is this: for every attribute, right, that I have, I will try to pick another attribute, okay, that tends to split the data in the same way. Right. Suppose let us say, again let us take the same example, I have 100,000 data points, I split on attribute say 3, okay, and I get 2 groups, right. This has say 70,000 data points, this has another 30,000 data points. I split on some another attribute, let us say 4, okay, and again I get 2 groups, one has 68,000 data points, other has 32,000 data points. And not only that, it turns out that the intersection of this 70,000 and 68,000 is something like 65,000, and the intersection of the other 2 is something like 25,000. So, essentially 3 and 4 give me more or less the same splits.
It's like we are finding correlation.
We are finding correlation, we are not really reducing it here. So, we are finding correlation. What we do is, if we had selected attribute 3 to split on our tree, and then we suddenly find that attribute 3 is missing in the data point, we just split on attribute 4 and behave as if we split on attribute 3 and go on. So, this is what I mean by surrogate, right, it is like putting proxy, right. So, I have attribute 4 can put proxy for attribute 3 and then you just continue working with your tree, right. So, that is essentially what surrogate splits are, and it does, it exactly finds that, right, it actually looks at correlation between the attributes and tries to exploit that, okay. So, as you can see that imputation, right, and adding these new categorical values could work with any kind of classifier that you are working with, right. I mean, as long as you have a way of handling categorical attributes, it is just one more value that you are handling, while the surrogate split something very specific to trees. right. Likewise, we are going to look at fragment, which is also something very specific to trees. So, this is a little subtle. So, what I am going to do is the following, right. So, I will come to a point, right. I am going to make some query, I am going to make is x3 less than 5, that is a query that I am going to make, is the variable x3 less than 5, that is a query I have to make at this point in the tree, right. And what do I find? My data point does not have x3.
You wanted to use the missing tag?
Huh?
How would you use the label missing again?
That is for categorical, right. We are talking about categorical attributes, so it will be like, okay, I am going to R, M, B, Y, G missing, like that, right. Or if I am going to do it into subsets, I will put missing into one of the subsets, right. But suppose this is there, x3 is less than 5, so what do? x3 is missing, right. What I do is I look at all the data points for which x3 was not missing, okay. I will see what fraction went down this way, let us say 0.6 went here, 0.4 went here. So, what is 0.6? All the data points that did not have x3 missing, 60% of those were less than 0.5 and 40% of those had x3 greater than 0.5. So, now what I do is I am looking at one data point, right, one data point that came here, I am going to split it into 2, right. So, it is going to 0.6 of the data point is going to travel down the left and 0.4 of the data point is going to travel down the right.
What do you mean by that?
So, what I do is it is essentially I am actually letting the data point travel all the way and it will reach a leaf, right, and the leaf is going to make some prediction. So, with some probability it is class 1, some probability it is class 2, some probability is class 3, right. So, the 0.6 part will make one prediction, the 0.4 part will make one prediction, I will make a weighted combination of the two predictions and I will output that as my final.
So generally, is it running through both the branches?
Yes, it is. Seems like quantum mechanics, right? Yeah. So, let us say I go down, I finally reach here and I say it is class 1 with probability, I do not know, 0.6 and class 2 with probability 0.4 and this one winds down somewhere and I say this is class 1 with probability 0.2 and class 2 with probability 0.8, right. So, overall thing that I will report is, okay, the probability of class 1 is okay. Does that make sense?
Why are you making it twice? Is it you're using the weight initially as well, and you're using it at the end
No,
as well?
no, this is maybe this is a bad choice. Does that make sense? I am using it only once, right. So, what is the meaning of saying 0.6 of the data point goes down this side? It's essentially I will go all the way down and I will say that finally I will use the 0.6, right. I am not using the 0.6 anywhere here, I am just telling you what is the semantics of saying 0.6 goes down this way. So, the reason we are carrying this weight along is at some point further down the line if I have another missing attribute and I decide to split it, I will not be splitting 1, I will be splitting only 0.6, right. So, this can get weird, right. So, I can have a data point which has multiple missing attributes travelling down more than 2 paths until reach multiple leaves and then I eventually combine all the leaves. So, this is called I am calling this as a fragmenting method, right. Again this is pretty unique to trees. So, if you think about it, this is somewhat similar to doing multiple imputation.
Doesn't that mean that this particular value is dependent on the other values?
Was it?
This particular value is dependent on the other values.
Which value?
Other data sets are going this way and that way, so that because of that this one's behaving like
of course the whole idea is to use training data to make a prediction on this data point, right. The subject is predicated on using the behavior of other data points to predict the output of new data, right. So it should not matter, right. So the last way of handling missing values is something called EM, okay, it's expectation maximization, right, and it's going to keep cropping up all over the place as we go along, but we will do it, we will actually formally deal with expectation maximization much later. So yeah, just be aware that when we look at EM, this is one of the applications of EM, okay, handling missing values. I am not going to get into this because it is a pretty involved thing, and in fact if you think you have been having difficulty with any of the concepts we have covered so far in the class, you have not seen anything yet, right. So EM is the one thing which everybody struggles with when they look at it first time, okay. So we will come to that later.